In this video, we'll talk about even and odd functions and what it means in terms of functions, which is very different than numbers. So let's go ahead and dive right in. If we're looking at an even function, our textbook example is y equals x squared. So if we think about that, it's a parabola, crosses through the origin, and it's totally symmetric about the axis line, and that is the defining trait of the graph of an even function. Okay, now algebraically, what it looks like, your f of x is going to equal f of negative x. Now this looks a little weird at first, but if I think about it, if we take a look at y equals x squared, well, if I plug in 2, I get 4. Now, if I think about it, that's what would be here. So I'm thinking, okay, what happens at negative 2? Well, negative 2 times negative 2 is also 4. So it just is another way of writing what we looked at up here with the graph. We're just saying that, okay, no matter what, when I got something on this side, the same thing is true with the reflection. If I go out 2 units to the left, I'm going to be at the same y value. So depending on what you're looking at, you can test using this algebraic thing if all you have is an equation. If you have a graph, you can use our first method. Now, some more examples of even functions would be y equals x to the 4th, y equals x to the 6th, and then another one that's not necessarily a monomial function would be y equals cosine of x. It has the correct symmetry. So it's not always a monomial function. There are some of these polynomial functions that would be okay. So like y equals x to the 4th plus x squared would be an example. So it's not necessarily monomial functions, not necessarily exclusive to polynomial expressions either. We could have ones that look trigonometric. So let's take a look at odd functions. So similarly to even functions, there is kind of a classic example, if you will. Y equals x cubed. And what that kind of looks like is it comes up, it goes to the origin, and then snakes up. Now this has a couple of names for what kind of symmetry this has. A lot of textbooks will call it point symmetry. Also radial symmetry. The idea is the origin is the pivot point, and if you think about x cubed, you should be able to pivot this thing 180 degrees and it'll line up with itself perfectly. So whether you prefer the term point symmetry or radial symmetry, about the origin. So it's really easy with an odd function. If it doesn't go through the origin, it's not an odd function. So y equals x cubed, one example, and algebraically, what it looks like is if I plug in the negative, f of negative x, well, that'd be the same as if I have just negative f of x. Now again, this looks a little funny, but if I think about it, let's think 2 again. 2 cubed is 8. Okay, now if I go to the negative side of things, negative 2 cubed, well, negative 2 times negative 2 makes positive 4, times negative 2 again makes negative 8. Now, I could have just cubed, kept it positive, and then said, oh, at the end, yeah, it's negative, because of the odd power there. So really, this is just an algebraic expression of this point symmetry. For this to be true, this rotation, I have to be on the negative side of things. It has to be in the kitty corner quadrant, if you will. So again, we can use this to test if an equation is odd, if it satisfies this condition. So I plug in the negative and then I make the original expression negative. If it turns out to be algebraically the same thing, it's an odd function. Now some more classic examples of odd functions. We've got x to the 5th, x to the 7th, not y, forgive me there. We also have sine and tangent are also odd functions. They have that radial symmetry where if we rotate them back, they'll line up just perfectly. So again, doesn't just have to exclusively be a monomial or a polynomial function. Could also be trigonometric. Lots of functions fit in this kind of classification. Now, something that's entirely possible, unlike a lot of numbers, is that it is very possible for a function to be neither even nor odd. And I wish they had different terms for these things, because it is just inherently confusing. We like to think of numbers as either even or odd, with only very few exceptions. But by and large, functions, this is actually a very small set of functions that fall in both of these groups. So the vast majority of functions are neither even nor odd. These are just kind of helpful ones to get us going. There are a lot of the simpler equations, and it gives us a lot to kind of talk about as far as function analysis.